Okay, get out your workbook. Turn to the title page of the second trimester, even though it's not the second trimester yet. We still got a week on that. This is where we are, so I guess we're ahead of schedule, which is fine. And this would be the new page 54. As you can see, this is page 55. Maybe it'll show up right there. So we're going to go to the new page 54. There you go, right there. I got it. See? No, you can't see. 54. Okay. And then we're going to analyze some graphs and see why they are not good. All right, let's dive right in. So what I need you to do is I need you to pause the video and take a look at this graph and tell me at least in the workbook 2 things that you think are incorrect about the graph. Pause the video now. Oh, you have your 2 things. That's wonderful. So here's what I'm thinking. Whoops. Look at Chevy. Look how amazing Chevy is. Chevy is just dominating right now, the competition. Ford, Toyota, Nissan, they don't even have a chance. That's all you need to gain from this. That's what they want you to get from it. They don't even want you to read it. They just want you to see that Chevy is clearly better. But what we have a problem with is, well, this is a pretty common tactic when coming up with a persuasive graph. You just don't start at 0. So if you start at 95% and just kind of slice it right there, right through here, instead of going down to 0, then you give the perspective, like the idea that there's a lot of separation between these 4 when in fact there's clearly not. Chevy is coming in at 98 point some percent, let's say 98.3. And Ford is also doing well at 97.5. That's not that far off. But have you even looked to see what the graph is about? Did you spend enough time analyzing it? Probably not. Look up here. Percent of trucks that are still like on the road 10 years after they are made. Okay, so what we have here is 98 some percent of Chevy trucks are still out there 10 years later after they've been sold. That's really good. I would promote that as a company. Now, Ford is coming in at 97.5%. That's also really good. I would promote that as well. That's negligible. That's not statistically like significant to say that one is far superior than the other. But if you can pick a stat that you win at, like this one, how do you make yourself look better? Well, there's that. Now, there's also something else here that's subtle. I don't know if you noticed it. Look at Chevy again. Do you see how it's just slightly brighter in color and like it's contrast? It's a little bit whiter. And Ford is kind of like, a little dingy, and so is Toyota and Nissan. Poor Nissan. Look at that. They have like this much of a bar because of the way they sliced it at 95%. But there's still over 95% of their trucks on the road 10 years after they're sold. That's pretty good. So the 2 things I came up with is it doesn't start at 0, and there's a color discrepancy between the way the names of the companies show up. Okay, so that's graph number 1. Graph number 2. Oops. Here we go. Take a look. Pause the video now. And we're back. It would be really weird if you didn't pause it, because then I just look like I'm standing there or not doing anything. Okay, what'd you notice? Oh, look, the same thing. It doesn't start at 0. It starts at 53 degrees. Okay. And then we talked about color contrast in the last one, but this one has that going on in a different way. You have a change of color from a light, like goldish color, kind of pleasing to the eye, to a red, and also the idea of drawing your eyes upward. Okay, so you're going, whoa, what a jump. 2012 is just crazy hot. Now, however you feel about this topic, like this is something where you didn't have to do this to convey your message, I don't think. They're trying to get their message across that temperatures are rising. You also made a notice that these are out of order because it is the warmest years on record. And if you go from 2012 now to present day, they continue to climb at a pretty steady rate, and a 1 degree difference in climate is a lot, for like migration patterns of different species of birds and things, and what happens to the oceans when they go up a degree or 2, how it affects coral reefs. There's a lot of things that happen at 1 and 2 degree differences. So we don't want those things to continue to climb. But this isn't the graph that I would put out there, okay? It is intentionally misleading. You should draw your eyes this way, with the color contrast not starting at 0, to show discrepancy when they just didn't have to do that. Okay. Graph number 3. Let's see if I can get there. Ooh, okay. Let me move this out of the way. Take a look. Pause the video now. Okay, what'd you find? Same thing. You should have written this at least 3 times now. In your workbook, you should have written down 3 times that this graph also does not start at 0. Cost of gas, national average. And did you notice this one? Look at this. Last week, so this is like a week later, current. So it jumps from like a year to a week in time frame. That's not consistency in your graphs. You've not been taught to label graphs that way. That's not good. Like you need to have a incremental change that is consistent on your x-axis. Now, at least they're going up by 10 cents over here, which is consistent, but not starting at 0. For this graph, probably not that big a deal. But the reason why this line appears to have a steeper slope than it probably should is because you have a year compared to a week. Okay, that's something. Yeah, let's keep going. Graph number 4. Pause video. Did you write down anything? What do you got? You can tell me. It's okay. Oh, the percent's going up to 100. That's interesting. That's just, it has to be a typo. I mean, 52 and 58 adds up to 110%. Good try. But no, I don't see how you got that. Okay. That's pretty much it. Just be better. It's not even a graph. It's just 2 numbers on a page that are wrong. Graph number 5. Let me put me over here. Hey, you, over here. There you go. Okay, take a look. Pause video. Now. Okay. What'd you see? Is the x-axis consistent in its time frame? Looks like we jump 9 days because February ends February 28th. So yeah, they jump 9 days there. They jump another 9, another 5, 5, 4. Not terrible, but good try. Let's look at the y-axis. 0 goes to 5. 5 goes to 20. Whoa, hey, that's different. And this is in thousands. So this is 0, 5,000, 20,000. That's bad numbering. Good try. Do better. Okay, just do better with numbering graphs. Be consistent. Go by the same amount. It's not that hard. Okay, next. This one's kind of blurry. I know it's blurry. I'm sorry. Just take a look and see if you can figure it out. Pause the video. Write down anything you think is wrong. All right, here we go. Well, it's blurry, but there's something that happens with proportional change. Like when you take something and you scale it, you know. So if I were to insert just something simple, see if I can do this here. No, not that. Let's insert a rectangle. Okay. So I'm Burger King. And if I wanted to size this up in scale proportionally, if you make it twice as tall, you've also now the area has basically quadrupled. Okay. So you've got, if this is a length of 1, that's a length of 2. This area is 1 square unit and this is 4 square units. So that size differential between those two, it's not only taller, it's wider. It gives this like immenseness to it, if that's a word. Like, wow, look how large this is. So when you do that with logos, these look really small and they're all, basically the same height. They're trying to display like where they would hit on the y-axis with the top of the logo. But McDonald's, when you stretch it proportionally, it gets wider and taller. It's like, it is dominant. I mean, look at the numbers. You're getting up to 41 billion. That overtakes the gross domestic product of Afghanistan by double. Okay, that's a lot. But you really can't do that with graphs. Like you can't proportionally change them and put those two next to each other. Yeah, the one is going to be so much larger than the other. It's just going to engulf it. But you got to go with a bar graph that has just you're changing height. You can go with a line graph. That's fine. As long as the increments are the same. Start at 0. That's a good thing to do. Notice right here, it does start at 0. There isn't really an x-axis, but that's okay because it's just a bar graph with labels: Pizza Hut, KFC. So what have you seen? If you were to wrap up and talk about the things you've seen in this video, number one, not starting at zero is a big deal because it's going to change the perception of the height of the bars. Proportional change we just saw here. If you scale it up, it's going to then change area by a scale factor that's much larger than what you have around. If you do a pie graph or percentages, they should add up to 100. You have a color scheme where you can change color and also like bring your eye to the more appealing part. And if you match that, the color scheme change with also not starting at zero, you have something that's really effective. Like people who are not educated on this, they look at it and say, okay, this is too hot. Chevy's better. Let's move on. And they don't want you to spend a lot of time on it. Okay. All right. So go to the Desk Mouse activity on the webpage and do the next thing and do it well. And I'll see you guys tomorrow.